So we are doing question number 7 from Ready, Set, Go of 6.10. And we're going to go over how to, the directions are solve this right triangle. So if you remember, the very first thing that I've been teaching you is whenever you have right triangles, you have right triangle tools. And the very first thing you guys said, Ms. Johnson, we can use the Pythagorean theorem or we can use trig. And the last one is the triangle sum theorem. And then I remind you that it means 180 degrees, right? So you're going to use one of those things in order to solve this. Now, because they gave you two sides, it means that you're going to use the Pythagorean theorem. In case you forgot what the Pythagorean theorem is, that's why I'm here to remind you. It's leg squared plus leg squared equals hypotenuse squared, right? And so don't make the mistake. This guy's your hypotenuse. He belongs over here in 18 squared. And this is 17 squared and plus leg squared, right? And then we just do a bunch of math. And so the math that I'm going to be using is on a calculator just so I can get this. So I'm going to do 18 squared, and that's 324, is equal to 17 squared. I actually know what 17 squared is, but I'm going to show you that I use a calculator. Oops. So we get leg squared is equal to whatever 324 minus 289. Oh man, you were right. I'm sorry. I said that you needed to check your answer. I was thinking something else. She's laughing at me. Okay, very good. So then we take the square root of it. Don't forget, whenever we take the square root, we also include plus or minus. As it sits right now in the class that you're currently in, we throw out the negative because according to your thinking is sides of triangles can't be negative. But next year, they can be. So the square root of 35 is your answer, which is about, let's see what that is about. I don't know off the top, 5.9. So there you go, 5.9. Okay. So give yourself give yourself let's say 2 points. Like let's pretend that this is on the test tomorrow. Give yourself 2 points if you got this far. So maybe I'll put this in this color here. Give yourself 2 points if you got the square root of 35 or 5.9. Okay. If you didn't get that, figure out what you did wrong. No, I don't know how you got that. Um, no, it's not close enough, dear. I don't know what you did. There's in my head, I can't see how you got 6.32. Check your math. Okay. Someone said, do we need to put the decimal form as well? No, you don't have to, unless I ask you to. Unless I say, hey, how much is the decimal form? The other reason that I would use the decimal is if I was given a context, as in feet or yards or word problem. Because imagine me going to, Home Depot and being like, hey, can you give me square root of 35 yards of fence? Dude would look at me like, what? Right? So context matters. So for the most part, I'm not taking any points off if you don't put a decimal or if you do. Just follow directions, I guess. So the next thing that you have to do is you have to find the angles. Now, we've used the Pythagorean theorem, check. So now we're going to use trig. So which trig ratio, I'm going to start with A. Now, if you were listening to the other video, Miss Johnson, she always uses the information that they give you and not the information, thank you, not the information that I found. Because if I made a mistake, like say my answer was 6.8232, my bad, 6.32, then all my answers are going to be off, right? So I'm always going to use the information that they gave me. So which side is this for angle A? What is this guy called? Yeah, this is called the adjacent side, right? And then what is this guy called? What's the 18 called? Very good, the hypotenuse. Okay, people have been doing their work. I could tell. Yes, yes, yes. Okay, so because they gave me the adjacent side and the hypotenuse side, because they gave me those two sides, right? Which one should I use? Sine, cosine, or tangent? So for those of you who still are a little bit shaky on this, my suggestion is that you say, well, they gave me the adjacent and the hypotenuse. So let me write so, ka, to, out. Which one of those involves the adjacent and hypotenuse? I know some of you are already telling me, Ms. Johnson, I already told you. Yes, exactly. So which one should I be using? Sorry, just trying to give out some points there. Very good. I should be using cosine. Very good. So we've been practicing, I see. We have been practicing, Miss Johnson. Okay, very good. So we're going to go with cosine of A equals to adjacent over hypotenuse, which in this case is 17 over 18. Is everybody okay with 17 over 18? Everybody okay with this? Anybody lost at this point? No, we're good. Okay. So then what I say is, oh man, my variable or my x is stuck in cosine. How do I get them out of cosine? Very good. You already knew my question, huh? How do I get them out? How do I undo that cosine? How do I undo that cosine? I only got one person so far. No, don't multiply it. So when you say multiplying is because you think that cosine is being multiplied by a. No, and we're not dividing either, right? So we can't do those things. So I'm just going to tell you, you take the cosine inverse of both sides. Everyone say cosine inverse. Cosine inverse is it's the inverse of cosine. I know that sounds obvious. But what it does is it undoes cosine the same way that division does to multiplication, to adding and subtracting, squaring and square rooting. Okay? So all that's left on the left side is A equals to cosine inverse 17 over 18. So take a second, memorize that part right there. So if you didn't know, the way I get A out of cosine is by taking the inverse. That's a huge key for your test tomorrow. I mean, Friday. And then it's also a huge key in terms of understanding the rest of these homework problems. Okay, so take a second, remind yourself, how did she get A out of cosine again? How did she get A out of cosine? Put it in the chat for me. How did I get A out of cosine? Okay, 1, 2, 3, 4 of you got it. Good. What about the rest of you? Keep going. How did I get A out of cosine? Yeah, I legit want every single person to write it. No, not the Pythagorean theorem. We cosine inversed it. We used the inverse of it. See right here? At this point right here, oops, that was supposed to be a highlighter, my bad. At this point right here, we have A stuck in cosine. So I'm bringing you back to 6th grade. So if A was stuck in multiplication, how do you undo multiplication? Division, correct? So now I'm like, well, how do you undo cosine? Cosine inverse. Does that make sense? Very good. Okay. So later on, you're going to see over here, I don't know, maybe down here or maybe this other problem. It's going to show you sine of something equals something. And you're going to be like, my variable's stuck in sine. How do you get your variable out of sine? How do you undo sine? Right? How do you undo that? Exactly. Sine inverse. Okay. So you literally take this thing and you plug it into your calculator. So you take exactly what you see, cosine inverse, that's in here, and you go 17 over 18, and then you're done. Whatever that is. Now that looks like a wrong answer, so I'm going to make sure that I'm in degree mode. And so, yeah, now it's 19 degrees. So that's about my answer. A is about 19.2 degrees. So I'm going to squeeze that guy in there. He's 19.2 degrees. Everybody okay with this? Then I say, okay, well, now I have to find B. How do you find B? How do you find angle B? There's a couple different ways you can do this. There's my tools again, in case you didn't know. Yeah, you could do opposite. You could use sine, cosine, and tangent, or right, or you can use the triangle sum theorem, which goes like this. I'm going to take 180 and I'm going to subtract off 19.2 and the 90-degree angle, and whatever I'm left with, that's B. So 70.8 degrees. Oops. Okay. And there's my answers. So here I got A. I got this side here, and I'll just write B equals 70.8 degrees. Yeah, someone picked up on this little thing that I put. So whenever you see me using this little symbol here, it's called an approximate or about. I can't write A is equal to 19.2 because look at all those numbers that I chopped off. Do you see all those decimals after I chopped all those off? I rounded it. So equals literally means exactly the same value. Okay. Okay. So I want you to look at this and say, oh, this was the hardest part. What was the hardest part? Was it the Pythagorean theorem? No, not the Pythagorean theorem. You guys are all okay with the Pythagorean theorem? Good. Was it labeling or was it figuring out which one I should use, so, ka, or toa? Was that it? Some of you said yes. Okay. So whenever you're trying to figure out which one I use, I always write so, ka, and toa. Very good. And then I'm going to do it based on the two sides they do. Very good. And then so someone's like, no, I know how to do that part, Miss Johnson. It was really learning that the way I get A out of cosine was cosine inverse. So whichever part you're struggling with, that's what you should really work on. That's the part that you need to work on. Okay. And is anything here undoable? Like, I don't get how to do this. Yeah. Very good. Okay. So this is one type of solving problems when I give you two sides. Here's a completely different one. What did they give me for this one? What did they give me? The hypotenuse and an angle. Very good. So clearly, I'm not going to be doing the Pythagorean theorem first on this, right? Because I can't do it. All right. So the very first thing that I want you to decide is who, like, since I can't use the Pythagorean theorem, I'm going to use, yes, very good. What's the other tool that I am going to use? Very good. I'm going to use trig. Now you get to decide which trig function you want. So you guys already know, I don't know why. I can't explain to you why sine is my favorite. It just is. And so whenever I'm given a choice, I always use sine. I don't know why. Don't ask me. It doesn't make sense. They're like, Miss Johnson, why is it your favorite? I don't know. So I am personally going to use sine. So can you figure out which angle you want me to use, and then which, you know what I'm saying? So let's do that first. Can you find the other angle? Is that the next thing that you guys can find? Can you find angle A? What is angle A? Love it. Very good. What did you guys count? Yeah, exactly. How did you get that? Some people put in the chat 30 degrees. Where the heck did they get 30 degrees? Yeah, they said, "Hey, Miss Johnson, if the whole triangle adds up to 180 and you got 60 plus 90 is already 150, that means 30 has to be left." Very good. Okay, if you didn't see that, that's, remember how I tell you guys my tools? It's my third tool. Okay. Okay. Okay, so then from there, wait, this is a 30, 60, 90. This is one of our famous triangles. Do you guys remember our famous triangle? If you say no, that's okay. I'll teach it to you. Okay. So if you don't know our famous triangle, I'm gonna make you remember him. He needs to be known, meaning this is another one of those things that if you know how to use your 30, 60, 90, it's like the multiplication tables for sixth grade. The more you knew your multiplication tables, the easier you made sixth grade for yourself, right? Okay. In a 30, 60, 90 triangle, oops. The side opposite of 30 is x. The hypotenuse is 2x. And the other side is, oops, x root 3. Okay. And you guys are like, how does this help you, Miss Johnson? I'll show you. So then once I figure that out, then I superimpose this triangle onto the other ones. So I'm going to write opposite side of 30 is x. The hypotenuse, what's the hypotenuse? What am I going to label? Yes, exactly. Yes, it's 2x. Very good. And what's this longer leg side? Very good. Yeah, x root 3. Very good. So very good. Someone's like, Miss Johnson, I already know what x is. Okay, good. Tell me what x is. Everyone go find out what x is. Yeah, it's 10. So if 2x equals 20, that means x equals 10. Is everybody okay with that? Yeah. So if x is equal to 10, then x is equal to 10 over here. And then, Ms. Johnson, do I just put 10 in front of the longer leg side? Yes. 10 root 3. Okay. So whenever I recognize the 30, 60, 90, I use my 30, 60, 90. No problem, hon. Okay, so you didn't have to use that. You could have used sine of 30 to do this. So I'm just gonna, this is an alternative way. I just want to show you the alternative way. So can you guys write the equation sine of 30 degrees equals to what? Looking at this equation right here and the triangle, sine of 30 equals to what? Right? Yes, very good. So it's equal to the opposite, which I'm pretending we didn't know it yet. Is that okay? So I'm going with x over 20. Do you see this equation right here? This is an equation that we can solve. So how would you solve this equation? Meaning, how would I get x by itself? What's happening to x? Yeah, it's being divided. So take yourself back to 6th grade. When you had a division equation, how would you undo your division? You guys are like, oh, Miss Johnson, you multiply. Exactly. Little 6th grade you would have said, multiply both sides by 20. Okay. Some of you are like freaked out that there's sine of 30 on that other side. Who cares? I'm going to plug all that into the calculator anyway, right? Okay, so then the 20 divides by the 20 and I get x. So x is equal to 20 sine 30 degrees. So then in comes my calculator, which for those of you who don't know, the sine of 30 is something that you will learn like almost by heart later. There it is. Boom, it's 10. But Miss Johnson, we got 10 over here too. The answer matches. So I'm a huge fan of using two different methods to verify my answer to make sure that I'm absolutely correct. So if that's you as well, do it. Right? And then from there, because I know two sides, I could always use the Pythagorean theorem. I could use the cosine of 30, whatever. Yes, absolutely. Absolutely. Okay, so again, looking at these two problems, let's say that I give you a problem or two like this on the test. What part is going to mess you up? So for some of you, you're like, I don't really like that 30, 60, 90 business, Miss Johnson. Technically, you don't have to use it because you could have used sine of 30, just like I said, right? Some of you are like, Miss Johnson, when A is stuck in that cosine, okay, then write yourself a little note. Like, what note would you write yourself? Let's see. Let's pretend that we're writing ourselves a note. By the way, when I used to write notes to myself for in my notes, I would like almost like tell myself to not forget something. So don't forget, maybe. Okay, so what should I write in this little thing? This little reminder to myself. What could I say? Don't forget, because someone said, Miss Johnson, that cosine inverse business, that's the hardest part for me. Why did we bring that in the mix there? Oh, someone says, don't forget sine SOHCAHTOA. Very good. But why did we bring in this cosine inverse? What made us bring in cosine inverse? Look at this part. Cosine. Yes. Very good. Okay, someone said it. So when variable is stuck in cosine, and you could similarly talk about sine or whatever, is stuck in cosine, take cosine inverse of both sides. So then I put a little like, this is my little notes to myself. Whenever I do notes, I put it in a little bubble because those bubbles pop out at me. And then now I know to look at that when I'm studying. And then while I'm taking my test, it's almost like those bubbles, like I can remember what I wrote in my bubbles to myself. So figure out which part is the most difficult part, and let's um, make sure that you don't mess up on your test on that. Okay.